right, awesome. This is my utmost pleasure to welcome to the stage the author of the tech that will blow the minds of every Linux and Mac user. Graphical application for file exploring, searching, file pilot. Please welcome, round of applause for Vjekoslav Krajačić.
Thank you, Łukasz. So, hello, everyone. I'm going to go and start with a joke because apparently we have a technical problem. A lot of people cannot pronounce my name here. And roughly 50% of people think that I'm from Russia. And apparently, Tweaking File Manager were popular there back in the day. But I'm actually from Croatia. So it's a small country on the Mediterranean. It has extremely diverse landscape, from mountains and beautiful coastline to wheat fields. And it also has it has a long history dating back to 7th century. It's mostly Catholic country, at least on paper, though I try to live up to that. And yeah, you should definitely visit if you ever have a chance. So what's my story? Why I'm here? I'm the creator of File Pilot. It's a file manager that's currently available for Windows only. It's in beta. And yeah, I started writing this roughly 3.5 years ago. And it was pretty much written from scratch. So the topic of today is going to be me trying to explain at least some parts of the code. And yeah, a background about me. So prior to working on File Pilot, I was actually a co-founder and I ran a game development company with my friends for more than a decade. The company was also based in Croatia, and we shipped games to millions of users, players, on Steam, and on mobile, web, and even consoles. And my job there wasn't game design. It was mostly of technical nature. But one very useful thing for me was that I learned how to finish a project and how to push something to the end users or players. So yeah, even back there, back in my old company. So I left my old company in 2022 to start working on File Manager. But even prior to that, while I was in my company, we used to watch this one guy who was programming a game from scratch every night. And it had a really big impact on how we programmed in our company. Even though we actually didn't, we used commercial game engines to ship games, but it wasn't. So we completely ditched object-oriented programming, which was the topic of today, and we started writing a more straightforward procedural code. And so it wasn't so uncommon for our projects to have like scripts spanning tens of thousands of lines of code instead of small scripts. I think that we pretty much broke every Unity recommendation ever had. And people coming to our company usually were a bit confused because we wrote software in a really unconventional way for Unity games. So at that time, I had a toy project I was working on in my free time. It was mostly serving as a playground for the things that I had learned from Handmade Hero and other similar resources. It had only a basic file navigation stuff. It was codenamed Disk Voyager at the time. And at that point, I had also been a user of Total Commander for maybe 5 to 10 years. So I was already aware of the file managers, at least on Windows, the landscape of file managers, and many of those were definitive improvements over File Explorer, which is not hard. But they were still showing age because a lot of them were written like in the 90s, so in early versions for early versions of Windows, and some even prior to that. So I saw a good opportunity for the business perspective. This is my prompt engineering skills in generating images. So I saw a good opportunity for writing a file manager from a business perspective, because I thought that pretty much everyone who is using PCs for the work is using file manager to some extent. So yeah, it was a tough decision because I had 3 kids at the time, but I talked to my wife and she gave me her full support. We had some savings. I also got some money from my old company, so I decided to give it a go. But I couldn't help thinking myself, so what happens if I fail at this project? What happens if I spend all our money? And there was this meme that was circulating quite a lot at that time, and it stuck with me. Anyway, fortunately for me, and for you, Casey, that didn't happen. I shipped File Pilot early this year, and reactions were really good. It even took me by surprise. So I want to try to explain why do I think that people reacted this way, and why do I think that it corresponds with some of the design goals I had for File Pilot right from the beginning. So probably the first thing that stands out when you download a File Pilot is that it's only a 2 megabyte file, and this is something that a lot of people cannot comprehend today. We are pretty much people obviously don't know that we used to ship software like this, and this even sometimes this even hurt because a lot of people complain that Windows is complaining that this is a virus, and I did sign the executable, and it's probably the worst money spent ever, because it obviously doesn't help. So the next thing is it's a standalone executable, meaning that you don't have to install anything, which is also something that people are not accustomed today. So usually you will stare at these installer screens for minutes as it scatters junks on your PC, like background services and registry entries and who knows what. File Pilot does have optional installer, but it's so simple, it's embedded into the executable, and all it does is it copies executable wherever you want, and it has a couple of options. I was so lazy with that, I didn't even multi-thread the code that copies the file. Like, it's so small that like it doesn't matter. So yeah, it's completely optional. The program works without it, and I know that a lot of people really appreciate that. So the next is startup time. File Pilot is launching pretty fast, at least for today's standard. This is a picture of a profiler. I apologize for the tiny text. But I wanted to show that most of the time spent booting File Pilot is actually OpenGL initializing its context, and Windows showing its window. So the horizontal axis is time in milliseconds, and the vertical axis is number of threads. So the way I mitigated this is I tried to preload as much stuff as I can while OpenGL is doing its stuff. So I will usually preload fonts and icons and files and stuff like that. So by the time that Windows is done and ready to display the window, I will have pretty much everything I need to display it to the user. Next is speed. This is probably the most important one, and it's the one that a lot of people are really happy about. So File Pilot can index millions of files in seconds on modern hardware, and It's weird because I'm actually using very old Win APIs from the 90s to do that. So this is pretty much on the hardware, not on the me. But in the future, I plan to support directly reading master file table from the disk. So these operations will probably take like it will be instant for pretty much anything. But it's not only the raw indexing speed, it's the responsiveness of the whole UI, which a lot of users is really liking. Then there's UI. This is something that was very important to me right from the start, because I think that most screen real estate should be used to display files and file contents, and not the actual UI. File Pilot, a prime example of that would be command palette. So a command palette is not visible by default, but it can easily be summoned by a simple hotkey, and you can filter pretty much everything you can do with File Pilot. You can also rebind hotkeys here. Also, the fact that I'm using this as a showcasing program on stage is kind of proves my point. The UI is real simple. And finally, there's personalization or configuration. And this one is probably the toughest one for me, because I think that each program should pretty much work like it is from the start. Users should not configure anything. Too much options usually show there's some leakage in the core design. And File Pilot is trying to be very modest here. So I offered a very couple of options here, mostly related to files, and you can change the color theme and stuff like that. A lot of people on our Discord servers will often ask me stuff for new features, and when I tell them you can do that in some other ways inside File Pilot, they will usually tell me, okay, but can you add an option for that at least? So it doesn't have to be on by default, but adding options in that manner quickly becomes nightmare. You don't want to add option for every tiny thing. So it's really hard keeping this simple. File Pilot is currently in free beta, but there's optional pre-orders, and prices are a bit spicy. But I wanted them to reflect the engineering effort that went into working on this project. But I was actually kind of surprised, because File Pilot already earned enough money to repay all my debts and to sustain further development. And thanks. So this actually proved one important thing to me, and a lot of people have been telling me this, and that's that you can sell something very cheap or even give it away for free, but if it doesn't stand out, people will just not buy it. But if you make something really, really good, people will gladly give you even more money if it improves their lives. So yeah, I mean, the quality of the product obviously really matters. Okay, and just a couple of statistics. So from the start, File Pilot was downloaded more than 100,000 times, and I actually don't know the exact number because I missed tracking maybe first week or two when it was at peak. So I had to estimate those downloads based on the later traffic. So this number is very conservative. I would believe it's much higher than this. I received hundreds of emails, and even to this day, I receive dozens of emails a day. And it was actually kind of bottleneck for me, for my work, and probably not a smart idea to leave an email. But yeah, it is what it is. My Discord community grew from couple hundreds to couple thousands in just a few months. Sorry, Casey, about this. I was on the front page of the Hacker News, and I got a lot of YouTube reviews, even by some notable people like Scott Hanselman, and I received a fair amount of Twitter coverage, and it was all in very. I didn't pay for any ads. It was like mostly people sharing around. Okay, so File Pilot was I would say it was quite a success, at least from my standpoint. And why do I think that is, and why do I think that writing it from scratch was a very important part of this whole process? And that is pretty much summarized in this one. I think that speed really matters, and I think that it matters now more than ever. And it's kind of weird because a lot of people are trying to tell us otherwise. A lot of people will tell you that speed is just another feature, which is kind of bizarre proposition. And they can be quite dogmatic about it. They will say things like, human hours are more important than CPU cycles. But when they say human hours, they are probably referring to themselves, to the developers. But my question is, what about the other side of the equation? What about the users who are using your software and spending their time? And I want to be a bit more concrete on this one. So these are just made up numbers, but just to give you a perception, imagine that you have 1 million users and that each one is issuing one search request a day. And let's be generous to File Explorer and say it takes 1 minute to return results. We're talking roughly about 58 years of accumulated users' time each day. And imagine now that this search results in 1 second. That's roughly 60 times faster. And this is just 1 day, just 1 search, and just 1 program. We are using a ton of software each day. So can you imagine across the board the inefficiency we are dealt with because our software is that slow? And there's one other thing that I think that Ryan mentioned in the Twitter some time ago, and that is that speed is just the first order effect. And that means that it's great when something is really fast, but what speed gives you, actually, it opens opportunity for some new features that wouldn't have been possible if your program wasn't fast enough. So a good example of that in file managers and in other software too is search functionality. So a regular way for that would be you enter some search term in the search box and you wait on the results. And if those results are not what you want, you repeat the process. And what if you had instant access to the files, or if you had a close approximation of that? Well, in that scenario, why would you not just respond to each letter you type and just present the new files? And that's called filtering, and it's actually how FilePilot does it. So this wasn't my plan when I started doing this, but when I saw how fast I can index files, I just went with it. So FilePilot doesn't have traditional search functions. What it does have is a function to filter on files, and it has a function on flattening the folder hierarchies. So for instance, if you want to search across your whole drive, what you would do, you would go to the C drive and you would flatten the whole drive. And it would display all files on your drive in one listing. And then you can just apply filtering to that, and you pretty much have searching in real time. So yeah, I hope that a lot of people agree with me on this one. So this actually brings me to the topic of this day. How did I build FilePilot, and why was building from scratch such an important part of it? So this is the sketch of my project, broken down by modules. At the top, we have a base layer, and this is where most core code lives, where all other modules depend on. Then we have a platform layer. This is, in my case, currently only Windows, and this layer is it fetches files and thumbnails and everything I need for it. It also is respected for opening a Windows, closing Windows, getting input and stuff like that. Then there's a program layer, which is the biggest part of my project, and that part is basically it's organizing all pieces together, and the main goal of the program layer is to build UI for the user. And so when the user issues something like clicking on button, or it requests a new files, the program layer will will dispatch every request to the platform layer, and it will rebuild the UI. Then there's the renderer, which is currently in my case it's OpenGL renderer, but I plan to move to DirectX on Windows. The renderer is really simple because FilePilot didn't have any special needs. It's only drawing colored quads. And then I have a UI framework that was built directly on top of it. And this is actually the part that a lot of people are asking me about because it's the main thing that people recognize when they try FilePilot, the responsiveness of the UI. So the UI was written entirely from scratch also, and it used immediate mode kind of API for building it. And finally, I have a very small amount of tiny libraries that I will sometimes include. These are usually single header libraries from people I trust. And some people will be surprised by this, but pretty much every module corresponds to one big C file. Yeah, I know. I'm a big fan of big files. Splitting things into too many files actually doesn't help me in organizing my code. So currently my code base is at around 100,000 lines of code, and here's the intersection per each module. So more than a half code is written in the program layer, and all other layers form another other half. And roughly 10% of the code is generated. So my currently my project rebuilds in debug mode in 2.5 seconds, and I can't emphasize enough how important this was for me and for my development iteration cycle, because I can pretty much do whatever I want and test those things immediately, and it makes a huge difference because it motivates you to experiment with new stuff. This is my build system, which is a small batch script, which invokes compiler with a couple of options, and that's pretty much it. And yeah, it's crazy how this is faster than incremental linking, which was also discussed today. This is something that's very specific to, it uses Unity build, and it's something that's very specific to C and C++ code bases. It essentially boils down to compiling everything into single translation unit. Speaking of code generation, I want to mention one thing briefly before I go into code snippets. This is something I started working right at the beginning of the project. So C is very old programming language at this point, and it has some really annoying restrictions on how you need to order your function declarations and structs. So for instance, if a function wants to call another function, that function has to go above it, and same is true for the struct. And so what usually people do is they split the structs and function declarations in a separate file. And so what I did here, I prepended all my functions with a made-up word. I didn't have to do that for struct because I already had that. And so each time I hit a rebuild of my project, I make a prepass that generates another file that has included all the type defs for structures, and it has all the function declarations. And this not only saved me typing unnecessary code, but a really nice thing about this that at the level of one module, I could finally type code in any order I wanted to. So this helped me organize my code in single module in much more natural way. And this is just an example how it looks on the code. So I thought a lot about what to talk about today. And my first thought was I should probably go over all my layers. And as I started working on presentation, I realized this is not realistic. So I had to pick one. And I decided for the base layer because I think that a lot of people will mostly benefit from this what I'm going to show today. If you're asking me why did I not show something that's very specific to the Windows and how Windows handles files and stuff like that. I will be completely honest. It's because I don't want to. So I've been asked a lot of time. What's the most pleasurable things and most annoying things that I have worked on this project, and I always tell the same thing. I pretty much hate everything related to the Windows, and sometimes I regret I started a file manager. But yes, I work with very old APIs, and a lot of those are not documented anymore, and it's really hard to find people with whom you could communicate some of this stuff. So yeah, it's also a lot of that stuff is slow, so I pretty much always have to slap some cache on top of something from Windows. So yeah, I hope that people will not be mad at me for not talking about COM objects today. Okay, so let's start with the base layer. So base layer is something that you would call a standard library in more modern languages, but C is very old at this point, and so C standard library is seriously outdated, and quite frankly, I think it's useless at this point. So if you're starting a new project in C, you should probably not use standard library because it's very, very old code. So I'm going to start with some real basic and boring stuff and then move into more interesting stuff. So these are standard in more modern languages. C does have type defs for these, but since I type those a lot, I grew fond of shorter versions of those. Also, though I have enum wrappers for types. Sometimes I want to shrink. I want to pack enums into my structs into less bytes, but it's useful for me to see that this is still an enum. Then I'll have like a ton of utility macros, and I only posted a small portion of it. This is something that you just get into habit of writing as your code base grows. So those are functions like various conversion functions and functions for dealing with flags and stuff like that. Then I have a lot of pound defines for various platform stuff, like intrinsic functions, just so that my program layer can write against those, so I then don't have to change my program code when I go support other platforms. Then there's standard stuff like sorting, which I implemented using Sedgwick's algorithms book. Then I have a lot of functions for helping me with byte ordering, aligning allocations and returning bytes, offsets, and stuff like that. And those functions are not big; they usually have small implementations. But I found it very useful to it's easier for me to read that in code than writing finicky code like that all over the place. Mem copy, mem set, and mem compare are currently pointing to the Windows versions of those. Okay, I want to spend a little bit of time on memory management because it's probably the most impactful part that made me. It's most impactful part that made FilePilot be this fast, I think. So most people, when you ask them, even to this day, and this is certainly how I was taught at high school and in the college, people will usually tell you they think of memory in terms of stack and heap. So stack is just some small amount of memory that compiler usually allocates, and it pushes procedures on it and temporary variables and stuff like that. And heap is usually some magical place where you go to fetch actual memory when you need it. So people will then usually allocate for each small piece of data they use in program. They will usually allocate specifically for that data from the system, and this ends up in very, how should I say it? This tends to ends up in these very tangled hierarchies where it's very hard to check ownership, and it's hard to check like the overall memory usage. And so there's just a lot of room for the human error. And so this is where usually modern programming languages will try to fix this with some modern concepts like shared pointers or garbage collection or memory or Rust borrow checker and stuff like that. But one important realization for me was that you can actually avoid a lot of those problems if you architect your program a bit differently with respect to memory. So modern operating systems virtualize memory per process, which means that each process is actually getting its own address space. And so what that means that programmers can think of memory in terms of linear virtual address space instead of strict divisions between stack and heap. So also one thing that's important to know is that most of the time, if you are a more experienced programmer, most of the time you do know the lifetime of your allocations, and you do know the size of those, or at least you know some close approximation of those. So for this most common group of allocations, what helped me the most is to think about allocations in terms of grouped lifetimes. And those work the way that you ask the operating system for a larger chunk of memory, and then you manually slice it and give it away for each your tiny allocation you need. And these can easily be extrapolated to multiple grouped lifetimes. And important to know that on the span on my whole project, I might have to deal with maybe dozens of this, which is much smaller problem than dealing with thousands or tens of thousands of allocations. So and these are usually tend to be a bit more structured. They almost resemble the stack. So usually at the top you would have some main state that is persistent across the whole run of your program, and then you would have lifetimes for each frames and other lifetimes. And it's not exactly the state. It's not exactly the stack, because there are transit states that can span multiple frames. So and usually those will depend on the user. So a construct that is very popular for this kind of programming is called arena, or linear allocator. It's also sometimes called the zone. So it has a counter for the reserved memory it gets from the system, and it then commits that memory usually on a page-by-page granularity. And then it has a simple counter that gets incremented each time you ask memory from arena. And implementation for that is really simple. It's a single function that where you pass how much memory do you need. Usually you pass in alignment and you get pointer to that. And you can write some utility functions for that will help you push structs and array. And then those will usually auto-align allocations for you. And when you're done with that, you usually just clear or release the whole memory. So to come back to this simple example, I'm just going to try to show you how that would be written using memory arenas. So we would define something like employee and added arena for that, and then we would first push the memory for the array of employees, and then for each employee, you would push any extra data you need for that employee onto the same arena. And so the nice thing about this is when you're done, you actually don't have to go through each employee. You can just release the whole memory in one go. So group lifetimes are usually grouped in at least 3 groups. They can be permanent, and this is usually where we would call what we would call main state. So that's the state that's there for the whole run of your program. Then there's a transient allocations. So one good example of that would be frame arenas. Those are especially popular in games, but FilePilot also uses them. So usually you would reserve one arena for the frame, and at the start of each frame you would clear it, and in this example, let's say you want to respond to a hotkey or to a UI press. In that case, you would usually you would not want to respond to that somewhere deep in the stack, but you would queue that for the end of the frame, and then you would process all the hotkeys. And frame arenas are perfect for this because you know that your allocations need to live only for the duration of that frame. And so you would just push that hotkey and any other data about it to the frame arena, and then at the end of the frame, you would just go through all hotkeys and process them. And so at the beginning of the next frame, the arena will get cleared again, and that's it. Another example is, let's say you want to present a pop-up to the user. So how I would usually do that, I would bootstrap that pop-up onto its own struct, own arena, and then I would push to that arena everything that's related to that pop-up. And so when the user closes the pop-up, all you have to do is you just release single allocation. Then we have temporary allocations. In file pilot, those would be fetching scratch allocations, usually for some temporary stuff you need to do inside a function. So if you call this at the beginning of your function and at the end of your function, they are pretty much the same as you would use them as a normal stack, but they don't have the size limitation of a stack. And those can be nested, so you can have more scratches inside the blocks inside the function. And I just want to say that just using frame arenas and scratch arenas probably eliminated a lot of tiny micromanagement I would have from the short-lived allocations. So only using those two were already eliminated a lot of allocation. Yeah, okay, but what about memory use? Because this is obviously a linear block of memory, and when you're done with something, what do you do with it? So you have a couple options here. You can leak allocation, you can split allocations, or you can recycle allocation. I'm going to start with the first one. So imagine you have a couple of folders, indexes of folders, and each folder has its own arena. So it stores everything it needs about the files it loaded from the disk. So imagine now that at some point user starts deleting files for one of those folders. So now you have part of your files are no longer valid in your index, and it's basically wasting memory in your arena. And one of the things you can do, you can just not care about that, and because you know that these allocations are not they are temporary, they are transient, they are not permanent. So when the user goes to another folder, this whole block of memory will get released anyway. So sometimes you can afford to think about allocations in this way. You can split allocations. So imagine you pushed an array to arena, and then you pushed a lot of elements to it, and at some point array will have to resize, and since it can resize naturally, it has to realloc. So this is usually fine. I'm fine with this if we're talking about scratch arenas and small amount of data. But if you have if you're in a more permanent state and those arrays are really big, what you can do, you can just split allocation, and you can just dedicate separate arena to the array and separate arena to the actual elements. And then when you're done, you just clean the both arenas. And finally, you can actually try to recycle allocations. So this is a very simple example. Imagine you have a lot of objects of same size, and they don't necessarily have to be next to each other in arena. So at one point, maybe you start using one of those, and now what you do with that memory? So what you can do, you can put it on a free list, and for each object you do that, you just append to that list. And at some point, if you need one of those objects back, you just ask the free list to give it to you. And so you get it back, and the free list shrinks. So this is just a simple example, and for this concrete example, I have a very small generic type of code for pulling same size objects. It uses some macro tricks to get the type of the nodes. And this is an example how you would use it. So let's say you have let's say you have a queue of input events, and we have a free list for those. So at some point you want to push a new event. So instead of going directly to the arena, what you would do, you would ask that from a pool, and then pool would check if there's free nodes in the free list. If no, it will give you directly from the arena. And the opposite is true when you go process those events. You can just give it away to the pool, and it will store them. So just a couple of benefits of grouped lifetimes. So the first one is simplicity, probably the biggest one, because using memory arenas and grouped lifetimes in this way dramatically improved my management of the memory, that I don't longer think about it that much. The nice thing about arenas is that they don't impose a complexity of allocations onto the user code, and that's really nice. The ownership becomes very simple because you only have a couple of those arenas, and usually when you need to find out who owns this object or this data, you would just check which memory arena allocated it. Then there's performance. And this is usually gained because you don't actually do a lot of allocations. You pre-allocate a bigger chunks of memory, and the smaller allocations are actually just incrementing a single value. And finally, you essentially get a very efficient free, because you don't have to remember all the pointers. You don't have to have all the pointers to all the data you used in some group's lifetime, because you know that all of those went to the same arena, so you can just clear it in one go. And if you want to know more about this, you can go to the Ryan Fleury web page, because he went much deeper into this topic than I have time here. Okay, now I want to show some arena-based data structures and how easily it is to compose those on top of arenas. So the most simple ones are linked lists, and unfortunately, linked lists are the ones that got quite a lot of undeserved hate, and a lot of people will tell you that that's because they are not cache efficient, but that's actually. That actually depends on the way you store these nodes. So if you're storing them in the array, in the array or in arena, these would usually end up being very close next to each other. So it's usually not a big problem. So this is just an example of how would you use stack in file pilot. So stack is the simplest one. It only needs one link in the node for the next pointer, and it needs to know the link to the first one. Then we have a queue, which needs another pointer, so it can dequeue them from the end. And then we have a double linked list, which is the most expensive one because it needs 2 pointers, but it's also the most ergonomic one in terms of usage. You can do whatever you want with it. And these are my implementations of those. We don't have to go over those, but nice thing about it, when you use macros, you only have to do this once, and because it's a finicky code to write all over the place. So you write this once, and then you're pretty much done with it. You can use it throughout your code base. And here's an example of using linked lists. So imagine you want to push render entries to the queue, to the list. So you add the pointer to the entry, and when you need to push the entry, you allocated it onto the arena, and finally you just push it to the queue. And really nice thing about this, about linked list, is that nodes can actually be part of multiple lists. So if you also want to put those into free list when you need them, you can just add a new pointer, and when you need to put define a new list, and when you need to put it to another list, you just tell that to the macro that the name of the link is free next and not just next. Okay, then there's arrays. So in C, it's quite known that C doesn't have a native support for those. So pretty much all programmers have to write their own. If you're doing this in C, you have a couple of options. You can go with the macros, you can generate the code, or if you're not using it in too much places, you can always type it out manually. I went with the macros, and a good starting point for that would be Sean Barrett libraries, because he knows how to do a good API design with the constraints of the C. So this is also what I started with, but my API and design diverge from his, because I'm not a big fan of hidden headers. So what I do when I do arrays, let's say you want to have an array of floats. What I do, I directly embed array header into into it. So it's easier for me to watch this in debugger. It's also easier for me to pass this around, and because I know what it is. And this is just a couple of usage functions you can reserve upfront. You can push to it. You can add a stack of items. You can insert it in front, and you can iterate over it like you would in any other language. And this is implementation. It uses macros to get the size of the type it operates on, and it uses the array header metadata to count to change the metadata, how much it grew and what's the capacity. And pretty much the same. I applied pretty much the same technique for the maps. The only difference is that maps perform a lot more than simple array. It's a pretty straightforward API, so you can push stuff, you can get stuff, you can delete stuff from the map and stuff like that. So when you're using a map in file palette, first you have to define a key value pairs, and they have to be called key and a value, because that's how macros know how to get those. Then you declare the actual map, and you put the header in front of it. And then you can do all the usual stuff with maps, and it feels pretty much like in any other language. And this is how it looks behind the scenes in the arena storage. It has two lists. They are usually next to each other. First, it has a link. It has a list of key value pairs, and then it has a hash table that points into those items. And the nice thing about that is that since items are stored in flat array, the nice thing about that is that you can actually get index from some item in the map, and you can directly access it by index. You can also iterate all items in your map without using any hash functions. So that's kind of nice. And yeah, when you're done, you just release the whole map with Arena. Then we have strings, and this is one of the places where you just have to do something else, because C is using very, very old style of strings. And I actually tried to post some advice in good faith on Twitter a while ago that people should use length-based strings, and it was insane how much backfire I got for this. So yeah, this is how C is handling strings. So it doesn't have a length separately stored, but it will terminate the string with a null terminator. And so if you want to know the size of a string, you have to scan through all characters, and that's extremely inefficient. Yeah, it's also not. It's not flexible, because let's say that you want to take a slice of that string and you insert a null character there, then you've just corrupted the original string. So what you would rather do is you would rather define strings as a pointer and a length, and then you can do this stuff very easily. And in order for those strings to work like this, you need to know a difference between a string constant, a string builder, and a backing storage. So pretty much all strings in the code, when you think about them, you should behave like they are constants. So strings are not changed. Strings are usually created or loaded at one point in time, and after that they should not be changed anymore. And then there's a backing storage, which in FilePilot is obviously arenas. So this is just an example of strings. So it has a value and a length. String builder is just a string with a capacity, and string builder has very, very simple API. It has a single function. I mean, it's more function, but it goes through a generic interface just so that you don't have to think. So you can pretty much append anything onto it, and there's also separate function that acts as a sprintf, but it pushes the stuff onto the builder. And couple of functions how this works. So you can define string on the stack, but now you have the length of it. You can slice them from either direction. You can directly allocate them on the arenas. And if you need something more than that, you can just use builder and build the whole string in a couple of iterations, and then you just return the build buffer, and you consider that immutable string. And I want to mention one thing, and that's string and ownership. In a lot of languages, strings are usually considered like they have special syntax and all, and they are usually considered very special in terms of ownership. But in FilePilot, they act like everything else because they go through the same allocation schemes. So here's an example. Let's say you have a file, and you have a directory listing that stores those files. So each time you get a new file, you push that file onto the arena, and then for the same file you push the extra data, and those are usually strings like names and paths, and that's it. There's nothing special about strings in this manner. In arena, this would usually be packed like this. So there's a file, there's a name of file, there's a file, there's the name of file, and stuff like that. Short slide about string interoperability. So regarding the Twitter thread, so a lot of people there told me, yeah, but what about all the places where you need to pass the old style C strings? And so what I would say here, you just want to isolate those parts as much as you can. And in FilePilot, I actually use this in very, very few places, only in the platform layer. And I would usually just do it in the same time when I convert my UTF strings to white characters, because Windows is, yeah. So nice thing about this is that the rest of my code base can now think in terms of nice strings which are length based, and they are UTF-8. So it's, yeah. And one nice thing, when you control all of your code, you can actually experiment with some tricks. So a lot of time in FilePilot, you want to, let's say you have a path and you want to extract the file name. You would usually do that by searching for a token, and then you would split on that token. So a simple example of that would be, so you search for a backslash, and you give it a flag which says go from the backwards. And the ugly part about this is that you now have to check if it actually found that index, because you have to skip one to not include the backslash in your name. And so the way you can handle this, you can just provide another flag which says if you do find an index, just increment it before you return it to me. So now the slicing from that index is free of that if check. But now it doesn't work for the second case. Let's say you want to return empty string if the path is a drive. So this will not work because it will actually return C. So you can just introduce another flag which says if you fail, don't return 0, return count. And so now we are back again without the if. So this slicing stutter from a path index value will just work with anything that gets returned. And so it's so much nicer to write it's so much nicer to write splitting strings this way. Then I have a ton of code for math. We don't have to go over those. I have a lot of code for vectors and matrices and rects, and those are mostly used for renderer and for the UI. But since FilePilot has a lot of those, it's used quite often in my code base. And the last thing I want to end with is something that's very important that I learned using this type of code, and that's zero is initialization, or I think that Rob Pike called this make the zero value useful. And so if you look at these examples, you will notice that you can read all of those without ever initializing anything. Like if there are zero initialized, you can read how much memory Arena allocated. You can go over empty arrays. You can try to compare equal empty string. Same for the builder and same for the vectors and matrices and everything. And it's not just reading; it's also actually writing or pushing to it. So you can push to the Arena that hasn't been initialized. You can do the same thing for the arrays. You can try to split a string that is empty. You can try to push to the builder. You can multiply vector that is a zero vector and stuff like that. And even nicer thing about that, it preserves that property if you put all those variables in another struct. And now let's say we defined a state struct with a zero initializer. Everything below this still works because it doesn't depend on any initialization. And so this is really nice because when you have a lot of code and when you introduce new variables, you don't want to go throughout all the code where this variable could be used and start initializing it. So this also gets you out of the business of checking for the nulls. And cherry on top of that is designated initializers. That's something that's specific to C. So usually, if you pass zero to the initializer, the compiler will zero out everything, but you can actually pass just a couple of variables and call them by name, and compiler will still zero out everything else. And so this is a really nice way of initializing values. And you can even expand that to pushing arguments to the functions, and you can go out and push that behind a macro, and then you have like really exotic stuff. Like you can push optional arguments in any order to the function. I usually don't use this syntax quite often. I will use this for stuff that is very, very heavily used in my code base, where I know that this will save me some typing. But usually it's not worth the hassle. And yeah, even better, those actually stack. So you can initialize. You can use designated initializer for nested structures, and there are libraries out there that use this as a syntax for initializing, and it's actually kind of nice. Yeah, I think that's it. I wanted to talk for today. As I said at the beginning, I actually wanted to talk about more stuff, but I just couldn't fit it in this time frame. So if anyone got any questions about other stuff related to like building UI or like how did I handle threading and stuff like that, it can ask me in the Q&A. That's it.
So I should start off by saying thank you, because
thank you.
That file palette is my browser that I use for files now too, every day, and it's been wonderful. I'm sure a lot of people out there are saying thank you for this. So my first question I had from watching the talk was, you started at the beginning and you said it took about 3.5 years of like development time. I mean, not necessarily total development time, but like that's the span of time.
Yeah.
I was wondering, like, what's the breakdown of that?
You mean how much time I spent on individual systems, or?
More just, how did development go? Like, was a lot of time spent in getting the initial prototyping stuff done, or was a lot of time spent with Windows, like that kind of thing?
Yeah, I actually quite a few people ask me like about the UI, and I think that I rewrote my UI at least 2 or 3 times during the development. So because for initial phase, when I wanted to prototype, I just typed in the most straightforward code for the UI. And later, when I had some use cases for what I want from this program, I went in with the full implementation of it. Yeah, I think that I experimented most with indexing files right at the beginning, even when I didn't have UI, because I was interested in how fast can I get like all files on my disk. So these were like the first things that I tried before I even touched the UI. Other things than that was like building stuff, like building the core technology. And in general, learning stuff because this was my first native program. Like I've been programming for 15 years, but this is like my first native program. So yeah, there was a lot of learning experience.
Was there anything in particular that you felt like was there any big stalls in the project, or was it kind of just always like moving forwards consistently as you went?
No, I don't think there were any stalls, but there were definitely times when I felt like it's moving too slowly, because I was like, I could get in a state where I'm working on something and I'm very eager to try that out, and in the process of that, I need to write something else because I don't have it, and so this repeated multiple times to me, and it was kind of frustrating at the times. But after you cross a certain threshold, you're fine, yeah, because you have your stuff and you can go.
So you mentioned that you are using sort of the older Win APIs for getting the file listings now.
Yeah.
And then you mentioned in passing you're thinking of going to reading raw disk structures off the drive.
Yeah.
Can you elaborate a little bit on that? I'm interested to hear. So you even though it's extremely fast already, you think there's a speed win to be had here by changing the way you're doing it?
Yeah, that's also actually one of the first things I tried maybe 3 years ago. Windows is using NTFS, which is actually closed source, but people have reverse engineered it, and so there's resources out there on how file system lays out structures on the disk. And so actually there are other file managers that are already doing this. And it's so much faster because what you do, you essentially just pick up all the index that's stored in the master file table at the startup, and after that you just have to update it. It's so much faster than going through the Win APIs. Although I would say that I think that Win APIs are reasonably fast because I think that Windows is actually caching a lot of that behind the scenes. Yeah.
So you talked about 10% of the code being generated. Is there anything else in that generated code, or was it just it's just so that you can have like the declare anywhere kinds of stuff for functions?
No, that's one part. The other part is I have I'm generating everything for options and hotkeys, and so all the callbacks for the hotkeys and calling into options and command palette and everything, that part is generated, because when I want to add a new hotkey or a new options, I just write it in a straightforward txt file, and everything else just gets plugged in to the system.
Okay, so you kind of have your own little like meta language somewhere for generating those things, because it was a lot of boilerplate or something.
Yeah. Like if you want to, when a new hotkey, new command is introduced, like you have to patch code in like 5 places, and so I wanted to avoid that. Yeah.
Gotcha. Kind of changing the subject slightly here. One of the things that I noticed about FilePilot, and one of the reasons that I'm like an avid user, because this is sort of a have-to-have feature, is that it's like very stable, right? It's like I don't know if it's ever crashed on me actually, or really even had a situation where it hung or did something like that, where I was having the kinds of things that I'm come to expect from regular File Explorer or whatever, right?
Okay.
And so I was wondering, was there any particular things that you were doing during development that you think led to that? Because, for a file explorer, it's very important that it be stable, obviously, for people to trust it. And it seems like you were able to get there like really quick out of the gate to a place that's pretty darn stable.
Yeah. I would say that, first of all, there are people who it crashes too. But I would say that a lot of those crashes are usually not my fault. I mean, there are places where it is my fault, but usually it would even either crash in third-party code or in Windows, in the kernel. I don't think I did anything specific other than trying to manage memory, like I explained. I think that helped a lot about with just purely with the memory bugs. So yeah.
And then I guess my last question before we go to audience questions was, I noticed you specifically chose C.
Yes.
As opposed to like, C++, but without using a lot of the features, which is another option for that kind of code.
Yeah.
Was there, like, how did you make that particular decision? Because you said that this was your first native app, so presumably you didn't have like a long history of being like a C programmer from way, way, way back. So how did you make that decision?
I think I programmed in C++ from my high school, but just never in like, I never shipped anything in it. I don't know, like just a lot of stuff from C++ seemed like not useful to me. And so I saw that a lot of people who are using C++ is usually using some subset of it. So I thought to myself, maybe just using C is a natural limit to me, what I can use. Yeah, but other than that, I don't think, like, designated initializers is something that's specific to C, I think. So stuff like that is actually better in C. Yeah, I don't know. Other than that, I don't have a specific reason.
So let's go ahead and go to audience questions now, if anyone has any, and it looks like we've got a lot. So I guess we'll start with Sam only because he should probably get priority as the person who put everything together. Okay. But I totally reserve the right to listen to the question and then deny him the answer if I feel like it's not of a sufficiently high quality.
Okay, so I want to know about the zero initialized arenas. So it sounded like you said that you, for the pop-ups, right, you create some transient struct and there's a zero initialized arena on there. Mm-hmm. So I both am interested in exactly what OS calls are happening when you first push to the arena, like where does it go? Is it a chained arena? Is it a virtual memory and then you fill in as you go? Mm-hmm. And how do you recycle it at the end? What's the end of life for this thing?
So I use virtual alloc and virtual free. I have support for both chained arenas and like the big ones. So the big ones I will usually use for the data that I know that needs to be contiguous. But I think currently I'm defaulting to chained arenas just to have smaller ones. Yeah, and what was the last question?
Well, I'm basically worrying or thinking about how, like, do you have to worry about ending up with too many of these arenas? Because I'm used to using arenas, but not on something as small as there's a pop-up. But I guess maybe there aren't that many pop-ups at once? Yeah,
there are not that many pop-ups, but this was just an example. I try to push as many things as I can into smaller number of arenas when I can. But this was just a toy example to show you how you would usually, for a lifetime that is different than anything else you have currently, you would usually use another arena because it's easier for you. But yes, I think that my default arenas are very, very small. So I don't think of them as something too heavy because it's like it's one virtual call and then it's all pretty much just incrementing a single value. I also have some configuration on how big chunks of memory you want to commit. So if I know upfront that I'm going to use a lot more memory, for instance, if I'm indexing big folders, I will tell Windows to commit memory in bigger chunks, just to avoid going to the OS too much.
I'm curious, Sam, what are you doing that you're having so many pop-ups in the applications that you're writing that you're worried about the number of arenas?
Well, no, it's because I get to do both sides of this, so I'm very interested in what the OS calls look like for this, and etc.
I think I never got to the place where Ryan was in what place. One time he used arenas for every little thing. I remember you saying that, right? But that was just for experimentation or something like that.
Yeah, it was just when I was setting stuff up. It
Yeah.
was like basically like being super lazy about
Yeah,
it.
yeah.
And it was a very small number in the end, and it didn't really matter.
And it's still faster.
Yeah.
So next question. Let's go to Wasim.
I just have a question about managing the memory of strings, because I can imagine you're constructing a lot of strings while you're doing this. How do you deal with that? Because you're going from one folder to the next, all of this is cached, do you free them periodically? How do you manage that?
No, I think I actually covered that. Like, so when I start indexing files, like I will put pretty much everything related to a files to a single arena, like literally one arena. And I will have maybe a couple more just for the huge arrays of pointers, so I can easily sort files. But yeah, everything goes up there. So if let's say user renames a file, the old file just got stuck into arena, and I don't care. Like I literally don't care. You allocate a new string onto the same arena, and you point the file into that, and that's it. Yeah.
I wanted to pick a little bit at your OpenGL dependency. Did you ever consider doing like a software rasterizer? Do you have any like downsides from using OpenGL? Maybe just graphics APIs in general. Would you ever avoid it, and would that get you some sort of benefit as a native application?
I think that the only reason why I chose OpenGL because that's the only thing I knew at the time. Like, I started learning OpenGL maybe 10 years ago, and so I didn't know anything else, and it was just the thing that I wrote for my toy project. But I'm definitely rewriting for DirectX. About software rasterizer, I don't know. I mean, it would definitely be slower. Like the cool thing about this is you can like full screen the file explorer, the file pilot, and like open tons of panels and stuff like that and tabs, and it works. Like it can easily chew that. I don't know how software rasterizer would behave here.
I think the only thing I've run into myself is oftentimes the graphics driver will crash on my laptop. And then my program will be like black or like won't render properly or it'll crash or whatever as well. And so like that large dependency feels annoying at times for reasons that are not my fault.
I have that exact scenario. I have a bug that's been from the very early release of File Pilot. There's a bug in OpenGL driver on specific cards, and people will get black screen on the top, and they have to like patch some open source version of the driver into their folder just to remove that, and it's horrible. I know.
Let's go, Raphael.
Do you have any threshold of when you say if someone renames a file, you just keep putting it into the arena? You have certain thresholds where you're like, okay, they keep renaming files. I've seen 1 million renames. Do I recreate the arena, or are you just like, yeah?
No, because those would obviously be like heavy edge cases. Like I would rather not build around those because I'm looking at the most common case. I mean, yeah, sure. User can rename files and keep the file pilot open for 2 years, and it would probably accumulate it a bit. But does it really matter? Maybe we're talking about for the whole drive, my drive, that's maybe 200 gigabytes. It takes around 1 megabytes of index data. So we are talking like in the megabytes. So I don't know what you would have to do to start polluting memory with renames.
Yeah, I thought more about if you have an automated build system that generates millions of files and then deletes them and generates them and deletes them and generates them, like Unreal Engine builds or whatever.
Yeah, that would be specific. I would have to look into that. Yeah.
And the other one is, if it's working so well and not really crashing and super popular, why is it still 0.2 as a version?
It's actually in 0.5. I released it a couple days before the conference, and I was hoping to release it to the public, but people found bugs, so I couldn't release it. But yeah, I think I need to work on my release cycle because I've been working on this for like past 5 months, and I still haven't released a new version from the original beta. Yeah.
Switching.
Okay. Feel free to reject this question because I know you explicitly said that you do not want to talk about Windows. But I'm really curious.
Next question. No, sorry.
I'm just so curious about the new feature that you added, which is to set it as the default file.
Okay.
How you achieved that.
It's patching a registry, and it has its flaws. Like I just watched what other file managers do, and the problem with this is that File Explorer is not just File Manager, it's actually a lot more in the Windows, so you can't just replace it because it manages a lot more stuff than just File Explorer. So you can do certain things, like you can respond to the shortcut, you can respond to the pressing on folders on desktop and stuff like that, but you can't. I'm not sure. Like people have been asking me, I'm not sure if it's possible when you open a file dialog. I'm not sure if it's possible to hook into that in easy way. Like
you can replace the shell.
Yeah. What?
Use file pilot as the shell.
Yeah.
Well, he's talking about file dialogues inside other applications. Like I'm in Microsoft Word and I hit open, which there are ways you can sort of do that sort of thing, but it gets pretty hairy.
Yeah.
So questions again. Let's go up in the back there.
So how do you draw the text?
What?
How do you draw the text?
How do you draw the pictures?
No, the text.
The text.
Oh, the text.
I use direct write as a rasterizer, font rasterizer, and then I just push the text as regular quads. Yeah, but I still have work on that part because I need to work on batching. Yeah.
So the filtering or the text search is just like searching all of the strings. There's no index data structure more than having all of the strings in memory.
I'm not sure on
I
this.
think he's talking about the filtering. So when you do your incremental search,
Okay.
are you doing anything other than just brute force to just look through all of the stuff that you've got, or is there an index that you've built that's for accelerating searching by strings?
I mean, everything is in memory, but I don't have like any special structure to help me go. It's like everything is in flat arrays of pointers to the actual files. If you're asking, I don't have like any extra data structure on top of that to make the searching faster.
So for example, if you flatten, there's always a feature to flatten within a folder.
Okay.
Then would you like allocate the paths, like the path suffix from that folder?
Yes, when you flatten everything, like I go recursively. I ask Windows recursively to give me all files, and I just place them again into the same arena and into the same arena for the actual pointers, and it's really simple. I think that one of the reasons why it's so fast is because I'm not trying to do anything too smart, I think.
So got a lot of questions. Okay, back.
So how much fussing have you had to do with your list macros? So for instance, like a doubly linked list queue macro can get a little hairy. Have you like tried different implementations and tried to get it?
No, I think I stole those from Ryan. Yeah, and he stole it from someone else and stealing all the place. But yeah, I agree. Like, I mean, I would have wrote them myself if I didn't see Ryan did it. Like, why would I do that if he did it? But I mean, the important part of that is that you don't want to write code like that throughout your code base because it's calling for bugs. Yeah.
More questions? It's hard. I don't know. I need something to point. I need a laser pointer.
So I want to ask you about how you manage to separate your application logic from your UI logic. Do you have something like if UI button just called like platform layer, or do you have a thing where you like essentially accumulate actions from your UI side?
Yes. The result of UI is like the list of render commands that I send to the renderer.
I mean it the other way around. So for example, when a user presses a button,
Okay.
for example, open a folder, right? How do you open this? Do you just immediately open it in your application logic? Or do you just accumulate these actions, let's say at the end of the frame, and then at the end of the frame you just go
the other thing, yeah. I had example of that. Like, so for anything that's I never do any heavy logic in the places like building the UI or responding to the hotkeys. Like I always queue that for the and then process everything in one place, usually at the beginning of a frame or at the end of frame. Yeah, it depends.
This is like the hotkey example you showed,
Yeah,
right? Where you
yeah.
kind of pushed on, like
Yeah,
the user
yeah.
hit the hotkey. I don't know if you remember that part.
Yeah, I didn't
Okay.
maybe miss that specific part.
Oh, okay. Yeah. So I assume that everything kind of works through that sort of
Yeah,
system. It like pushes on a thing when you're going through the password.
Yeah.
Oh, okay. You know what? This is too hard. So we'll number our rows like 1, 2, 3. All right. So yeah, let's go first row first. So Dennis.
All right. So it's actually a follow-up on this one. Like when you do commands for the UI, I'm assuming you do a lot of asynchronous stuff for files, if you rename files or copy files and stuff. I'm assuming it's going to be a lot of duplicated code, or do you find a good abstraction for having these like longer running commands in the background that can either fail or take a long time or be aborted?
You mean, I assume you are talking about the way you structure with the you're writing a lot. You showcase how you love to generate the code for the multi-threading, like just like a regular for loop. I don't have that. Like most of my threading code is like just spinning the background jobs. I do a thread stealing pool that someone asked you, but yeah, I'm not especially proud of my multi-threaded code, but I think it's fairly decent. So
not talking about the performant multi-threading code, more related to the I/O, asynchronous I/O. Like if you
okay.
file, it could maybe take 5 seconds, or well, not today, but like half a second if it's a really large file to a network drive or something.
Mm-hmm.
And then you probably want a responsive UI where you can abort this action or something like that.
Oh, you mean what if I start a job and users abort this, and what I do with the background job?
Do you put asynchronous stuff like that running over multiple frames and give the user a chance to abort them? And in that case, how do you structure that?
I don't think there's a case for that. Yeah, where there's one case where if I'm indexing a folder, like a big folder, and the user like closes the tab. Are you talking about stuff like that? Yeah, I will usually send a flag to the thread workers, and they will abort as soon as they can.
But do you mean that if you rename a lot of files or copy files, does that block the UI?
No, everything is in the background. Like the only job of the program layer is to build the UI and respond to the input. Yeah.
So they are just regular tasks on the.
Yeah, everything is in the background, because anything else would be like, yeah.
Let's go one back now from there.
So you said at the end of the talk that you effectively had more to say about threading that you couldn't fit in, and I was kind of interested in anything that you found interesting as part of your process.
Yeah.
Specific example, maybe about the granularity at which you're grouping things into tasks that go up into your multi.
I actually went through a couple of phases with threading, same as with UI, and I still think I can do threading better than I currently do. As I said, I have a thread stealing pool, and I try to write something that's fairly easy to access from all places in the code. But usual pattern would be like, for example, let's say I start indexing files. The structures that store those files will each frame fetch data from those jobs. So it works. Every logic, everything in file palette is structured such that you each frame check if there's like new stuff that's new, right? I would say that probably the biggest win for me in terms of multi-threading is trying to minimize the points that where you need to synchronize. So, for example, a lot of times I will try to when I need to push a new background job, what I will do, I will usually copy everything I need for that job and then that job will work in its own memory space, and it's not concerned with anything that the main program is doing. So I'm trying to minimize the points where it needs to communicate. And then each frame, it will check if there's new results, and it will copy that memory back into the main memory.
So you don't end up with much of a kind of fork join architecture?
No, I don't think I have any of that. Yeah.
Next questions? You already got a question.
Wait, yeah, just don't pick me.
Okay.
I guess, how did the use of CMD instructions factor into your optimization of the program?
CMD, like vectorizing. Not much actually, because this is not my field. Like, I use it in a couple of places where it's so obvious I could benefit from those, like fetching bitmaps from Windows. Like, and I need to go through all the pixels to convert them or something. In these places, I will use CMD, but I don't think I use them like in indexing code or something like that. Yeah.
It's a general question, not very technical, but now that it's a successful project, the UI is very successful, the core of the project is very successful. What's next for FilePilot? Do you plan to expand it beyond to engulf more things that File Explorer usually does? Do you plan to go to other platforms or to web, or what's your plan for the future?
So my first plan is like to stabilize the Windows version, and I want to go into like full version. Because currently it's in beta, and I do have a couple of features I want for that, but I'm not sure how long I want to prolong that, because currently the program is free. So about other platforms, yes, but quite frankly, I'm not even sure how complicated that is. I don't know a lot about Linux and Mac, so yeah, we'll see. So the nice thing about the way I organize my code is that porting to new platforms should not, like, if you remember my diagram, like I hope I will only have to write another box. I will not have to write the program layer and the renderer and the UI layer. That's all cleanly separated from the platform layer. There's probably some parts where I didn't think through, that maybe like Windows parts leaked into my code, but I don't think there's a lot of that. So I hope it will not be too much work, yeah.
Okay, I have a bit of a follow-up question, I think, to that. It will be like the hardest topic for a developer out there, you know. So you are in the early access, but you already had great sales. What was your marketing strategy before the release, and whether hot Twitter takes a part of it?
I don't know about Twitter. Like, I genuinely tried to push stuff there that I learned, but I also tried to like show stuff that I'm working on. So it was obviously part of my marketing campaign. Yeah, what was the first part?
Yeah, what was your strategy for marketing before the release?
Actually, my strategy was quite bad. And I was lucky enough to be joined by the guy who was supposed to present, Dimitri, or is he presenting? So there is this guy who's super smart and has experience in this, and so he was willing to help me with this, because I think that my original idea was to sell FilePilot for like $15 or something like that. Yeah, so he helped me shape the overall structure of everything I need to include in the license, and he also told me a lot of things that I need to change on my websites, which I still didn't do, because yeah, I still didn't have enough time to change my website, because this is also the thing that I built from scratch. Like, I didn't do anything, like I didn't use any framework for my website. Yeah.
So our strategy is just to ask somebody who knows something about it.
Pretty much, yeah.
Are there any other questions? Because then I will actually let Sam ask a second one.
Well, yeah, so this is not a Windows question, but I want to know what is the good but doesn't exist async file API for not file contents, but names, directories, directory contents, indexing stuff.
Can you be a little bit more specific? What?
As in the naive thing you would implement is just like, I do a syscall and then we block until we can get what is the contents of this directory, right? But what would be like the good version of, like, how are you querying in these background tasks? How would you like to be receiving the data from the file system API?
Yeah, I don't think that Windows has anything like that. Like, so you have to do your own. So the Windows only has APIs to fetch files, so you have to do the work of pushing that to the other threads. Yeah, I don't know. I think that the main, like, one of the nice things about using arenas is that you can usually, like, I will receive thousands of files per frame, and I can usually, like, just batch allocate those onto my main memory. And this is probably something that speed up a lot, because if I didn't do that, I would probably have to, like, if I'm indexing 1 million files and I had to go, like, for each one, like, copy it to the memory, copy malloc memory for this file and for everything it has, it would be extremely slow. But I think that the arena was probably the key part why indexing is so fast, because I can just allocate everything in batch.
Oh, how many syscalls on average do you think you do per file? So if you're indexing 1 million files, is that 1 million plus syscalls that happen?
Are you asking about actual syscalls or just calls to some operating system service that may be mapped into your user space? What could you be more specific? Because this is Windows.
Well, now you've broken my question.
Thanks, Casey.
I'm trying to.
Do you know behind what happens? I mean, behind the scenes in the DLL?
Do you know whether it's going to hit a syscall?
Yeah, well, I mean...
Yeah, I mean, you'll see a kernel transition if you're tracing it.
Yeah, so that's... Well, okay, so maybe you can answer my question.
I'm just here to admit it. You got to ask it to him. And so the question is, which are you actually asking about? Do you want to know about syscalls or just calls to an operating system API?
I want to know about syscalls, because presumably, if syscalls aren't happening, then you could just do that yourself, right?
Okay. So I'm assuming you have not looked at this, but...
No, but I would assume not, because if I were doing like 1 million syscalls, I'm pretty sure it would not be that fast. Yeah, I'm pretty sure, yeah. I mean, I should check that, but yeah.
Do you have any plans for extensibility, like people being able to add like plugin-like stuff? As a specific example, I came across that you don't support WebP files in the preview panel.
Yeah.
I sympathize with not supporting to a degree. So I think the idea of allowing somebody else to implement a WebP parser if they really want it in some way sounds desirable. But it also seems like it might go against your fundamental premise for optional options in the system, where you want as few as possible. So is extensibility on the roadmap? Or?
Yeah, I mean, I've been actually fighting against that, but I'm not sure how long I will be able to do that anymore. I do think that I want to add some kind of extensibility, but I want it to be like very limiting in terms of what it can do. So it's only specific to like previewing other file formats. So I don't want to add like some generic scripting support for the whole file manager. I don't want to do that. Like that's like opening doors to a lot of stuff which I don't want to deal with. Yeah, but for file previews, that's probably something I should add, because it's not plausible that I will write previews for like everything that exists out there. It's just not plausible. Yeah.
All right. We good on time then? We good to end? Was okay. Then are there any last questions?
So since FilePilot is a commercial product, I wonder if you thought of like eventually when the trial period, when the beta ends, you think of allowing like a trial period that the users can try the application, and then like a pop-up appears of like, okay, it's time.
Yes, it will have a trial period. Yeah. I mean, that's like just standard stuff, like probably a month or so, and then I have to decide: will I just present the annoying pop-up? You should buy the license, and you click some button and you continue using it, or I will be more strict. I don't know. This is also something I've talked about with Dimitri, and the problem with trying to deny access to the user is you will just the users will just end up pirating it. So maybe it's better not to do that, so that user use your original versions. So at one point maybe they'll pay, and if they pirate it, they will probably never pay for it. So
I kind of wanted to ask you about that. What are your thoughts on DRM, and like how much are you willing to just enforce that? Because
none. Quite a few people ask me, like, there's no validation on my side. Like the program is completely offline executable, so I'm not doing any checks to my server or anything like that. I'm just like, if you want to give me money, give me money. If not, okay. Like I don't want to be like you should give me money. I mean, yeah. I mean the people who don't want to give you money will not give you anyway. So it's no matter what you do. So I don't think this is something it can be fought. Like it's the same problem with the games. Like I remember when back then when we released the games, like the literal same day we released it, like there is a pirate version on it. You just can't fight that. Yeah.
Any other questions? No.
Will you continue paying Microsoft to be able to sign your executables?
No, I'm not actually paying him. I think I picked someone else. But yeah, it's I don't think I'm not sure what to say about it. Like I mean, I'm not sure if signing executable is preventing Microsoft from thinking it's a virus. I think it does some other stuffs. I'm not sure. I'm not sure what it's doing, to be completely honest. Yeah.
It's authentically a virus. Yeah.
Since you brought up the malware thingy, but it isn't packed, right? There's no UPX packing of the exe. It's like it's just the binary is 1.8 megabytes.
Yeah.
There's no packing.
No. Even installer is just like it's built into executable, like, because that was easier for me than learning like how installers work. Like, okay.
I can tell you, that's the perfect way to do it.
Yeah.
All right. Any last questions? Oh.
I'm sorry to be another guy saying, I'm sorry this is a Windows question, but I do, as you're probably the person here who's delved the most into all the file API goofiness, I would like to hear one horror story of like, what is the silliest thing you encountered in that set of APIs?
Like the two most famous one would probably be drag and drop and eye context menu. That's for right-click menu. Those two, like, I have dozens of bugs about those, like on my Discord, and it will never be resolved because it can be. Like I've been approached by other by other developers from other file managers, and they have the exact same problems with the context menu and the third-party plugins trying to do their things. Like one of the worst decisions I think that Microsoft made is they allowed third-party developers to initialize their code for the right-click context menu on the main thread. And so a lot of people will ask me, like, everything is in File Pilot is fast, but when I click right-click menu, I see the spinning wheel. It's like, yeah, I'm sorry, it's not on me. Yeah.
I might be the person who submitted the most bugs about that one, because I have a ridiculous right-click menu that crashes the entire Windows system.
Oh, right. So this is a nice way to telling me that I should get to work, right?
What do you have installed, Sander?
Oh man.
Okay.
All of Adobe?
Okay. There it is. That's the A word. Okay. Any other last questions? Oh, we got. So the questions are like they're reseeding. It's like they went to seed and now they're sprouting again.
Final question. You mentioned at the beginning that people ask you about your favorite part about developing this and your least favorite part. You said the least favorite part is naturally the Windows one. What's your favorite part about writing all of this?
So I don't think I have like specific one. Like the whole the whole architecture of the whole. I like the parts where I need to combine stuff and see how they interrupt. So that's maybe I would pick UI. That's like I always wanted to I always want to write my own. So we used to work in Unity, and Unity kind of has its old immediate mode UI, but it was meant for the editor and not for the games, although we ship the games with that UI. But I always knew that that Unity UI is like very truncated part of what it can be. So as I said, I think I rewrote my UI at least twice. And I remember the last time I was going to do that, like I went for a week or two and I like read every possible article on the web. So I remember visiting like old forums from Old Rocket and stuff like that, where like John Blow and Sean Barrett and Casey like discussed like this. So yeah, this is probably the most fun part. Yeah, the UI. But pretty much everything else, like.
We still have time? I feel bad. You've had to answer so many questions. We should probably give him.
We do, but we should be rounding off soon to go to dinner. But we still have.
Okay, we'll take one more question if there is one. But we may have gotten through all because that was an infinity of questions.
This is more of a statement than a question, but as a person that worked at Bungie for 4 years on UI, saying that UI is your most like fun part is the exact opposite of almost every person's experience that's ever had to touch UI. Most people go into it being like, UI is going to be super easy, and it's 10 times or 100 times harder than they want it to be, and they don't know why, and they don't know why it angers them.
So what's the secret sauce?
I mean, this is probably the difference when you do something, like when you do a startup. I should not say startup. When you do your own company and do this with like, I want to learn new stuff and I want to do the best possible UI, versus like, okay, I have a project I need to ship and I need to make some kind of UI just to have it working. And I don't know, I honestly enjoy that. Like I learned so much about like UI is one of those places where you can learn a lot about APIs in general, like how various pieces work with each other. So I don't know, it was a huge learning experience for me. And I should thank Ryan for that because he wrote amazing articles to that, yeah.
All right, let's give another round of applause for Vjekoslav.
Thank you. Thank you.
And now I have to convince him to give me access to this apparent new version that is so.
Yes.
All right.